and
Right.
now it will be officially the morning planet.
Yep.
But it can be seen well north of the sun, about between 8 and 9 degrees north of the sun, if you do it safely. It's part
Yeah,
of the daylight imaging, like we're going to talk about it.
yeah.
It could be done in a careful way if the telescope is in the shade and it's bright enough to be seen through the finder scope. But you only see it as like a little thin crescent. I don't know if Venus is close enough to the sun to see the extension of the cusp. I'm not sure. But it's a
I
little
haven't
bit
I
too far
haven't had
away.
any luck with that so far, so I don't think that's going to occur this time around.
No,
Yeah.
I had to be within 6 degrees of the sun,
Yeah.
to see the extension of the cusp.
All right. It's 3:01. So, Tim, whenever you want to engage.
All right. All right. We're going to start our webinar for today. It's on daytime planetary imaging, and we are now live on our YouTube channel. So if anybody pops in over there, please hit the subscribe button, and that'll really help out our channel. We'll go through a few housekeeping items before we get started today. We are recording this for publication on the YouTube channel as well, so it's going to be available anytime to go back and watch it. Please, if you are not presenting, please mute your microphone now. I would appreciate it. Uh, at the end of the session, we'll ask for your questions at that time. And when you ask a question, please keep it focused of general interest and avoid elaborate background stories and other details. We want to keep this to an hour. And at the end, there's going to be a survey that's going to help us with further webinars. Our presenter today, Frank Melillo. He's the coordinator of the Mercury section. He's from New York. Has been a member of the ALPO since 1984, and he's made over 60 daytime observations over the last 3 years. And Greg Shanos, he's a dedicated observer, is observing reports to many sections in the ALPO, 300 in 2024 alone. He's observing from Sarasota, Florida, and using a 10-inch Meade. He's been a member since 2021, and he's very skilled at capturing Venus in ultraviolet light. Okay. Uh, a major warning when doing daytime observing of the sun. If the object's less than 35 degrees from the sun, you must exercise safe practices to avoid permanent injury to your equipment or your eyeball. If the target does not appear in the finder following your go-to slewing operation, sweeping the area must be done in small increments. And try to place the sun behind you or behind an obstacle so you'll be set up in the shade. Good advice. And do not target objects that are less than 15 degrees from the sun. I think these are common sense items. And the easiest thing to start with is Venus.
Yeah, that 15 degrees is especially if you're just starting off.
Right. And this is the agenda for today. Telescope alignment. Go to, is it required? Centering the target, focusing, viewing a laptop in the sunlight, filters, and what is the payoff and what's some examples. And now we're going to start the conference with Frank. Take it away, Frank. Frank, you're muted. Don't forget to unmute
Okay,
yourself.
yes, thank you, Tim.
All right.
Okay, yes, I can start off with when you think of the telescope or something like that, and you only think it's at night. But if you see a person with a telescope during the day, he must do solar observing, especially, got to be safe to observe the sun with this safety filter. But you only think that the telescope is only at night, but also you can do during the day too by observing the sun or even the bright moonlight, the bright moon. And what about the planets? So planets observing the daylight. So that's what we're here for. Um, in order to if you have an equatorial mount, a line up the telescope is a must if you have an equatorial mount. But if you are observing from home, I'm pretty sure, I assume that you know exactly what north is, then you polar alignment as close as possible. The alternate way is that a night before, you can set it up, the telescope with the tripod, and then you can do polar alignment. You can see Polaris. You can use Polaris as an example to get the closest north to us pole as possible. Then you can leave it alone until the next day. And when you have to do any daytime imaging, you already set up the planet. You already set up the polar alignment, and you just don't touch the tripod or the telescope, or you can take the telescope off, but just leave the tripod alone, where it stays and will stay in polar alignment. So,
Let's take the
so
next
that's
slide.
the way.
The next slide.
With that,
I was just going to suggest the next slide there.
yes. Okay. Yeah, it's like you know, if you can leave the telescope overnight, you can do early in the morning. If you have planning well in advance that you have to image the planets in the daytime for the specific reason, you can able to fall alignment before sunrise, and you just get the start and get the coordination and make sure that everything is aligning with the coordination, with declination, and the right ascension. Once you establish that, then you leave alone. Then you wait until the daylight to grab any any target that you want to choose. All right, next. Okay.
No, this is me.
Okay.
Okay. Well, everything Frank said basically is true. And okay. All right. Next slide. Basically covered a lot of this. Daytime. Okay. Basic principle. Okay. Fortunately, there's an app. Okay. Next slide. Let's discuss the app. There's a great app for the iPhone, and I'm not sure about the iPad, but you can see right here where the arrow points, there's a sun. It's called PS Alignment Pro, Poloscope Alignment Pro. It's available. It's only a one-time purchase, $3.99. And Android has something similar. I Googled Polar Aligner Pro for the same price. And it shows you the offset at night of where Polaris would be for polar alignment. But this isn't what we're interested in. If you tap on this button that shows the sun, next slide, you get this, it says daytime, no poloscope alignment. So this is kind of really neat. You adjust the telescope to the right, to the left, and up and down, and then you get, once you get this in the crosshairs there, you're polar aligned. Don't worry about any offset. That doesn't matter. Just get it as close to there as you can. Next slide. And I have an example here. So place the phone securely on top of the telescope. This is metal, but it's insulated here with this outer box. And also when I took this photo, I didn't take the dust cap off. So make sure the dust cap is off the telescope, the finder scope. Another thing too is make sure the finder scope is aligned with the main tube. I've had situations where I found Venus in the finder scope and it just wasn't in the main tube. And then when I found it, it was like, instead of being here, it was way out over here. So make sure you align it ahead of time. The moon is good. If the moon is out, you can double check and make sure. But a lot of times the moon won't be out. So just make sure you don't bump this. A lot of times it gets off alignment very easily. So then place your phone securely on top here and then move the mount right and left and up and down until you can see it's pretty much centered there. And then that's it. And then you're done. And then you place in what's called the home position. You're at 0 right ascension. Just put it level so that your right declination 0, and then you're all set to go. And I checked out this video. It's excellent. Uses this app and basically goes over everything I've gone over now. So next slide. So for me, the AutoStar 2 and Celestron will be very similar. Pick 1-star alignment, okay? And there's automatic, there's 1-star, 2-star, and easy. Pick the 1-star. Normally, if it's in the evening, pick 2-star because it's much more accurate. But for here, just pick 1-star. And then it'll take a GPS reading and then pick a bright star in the database that's close to your target. Once it slews to that star, hit enter. You won't see the star in the finder scope. It's still too lit up. And, pick a bright star like Vega or Capella or something, and it's still not bright enough. So just hit enter and it'll say alignment successful. And then just go to Venus. So next. And then, okay. I have another slide, but go ahead. Go ahead, Frank. This is your section.
Yeah. Okay. Thanks, Greg. Okay. Now let's suppose you don't have a go-to telescope like what Greg just talking about it. It's go-to amount require. Uh, yes and no. All right. But Greg specified that go-to will help to find an object by using the coordinations and all, or the finder scope and all. And well, my telescope is not permanently mount, so it's portable. So once you set it up, then that's when I do the polar alignment. Um, so I use star hopping instead of the go-to. And I'm not up to that point of using the go-to equipment, but I don't really have that on my scope. So the best way is to do hopping. So how can you hop without hopping the telescope just one star to another in daylight? You cannot see that. Well, you can start with the moon. Okay. So let's start with the moon because it's an easy object to see in naked eye, and you can start right from there. If you have to go to either maybe even Venus. Venus visible with the naked eye if you know exactly where you look. But if you got Mercury and Mars, then hopefully, then the moon will be up that particular moment. So you can able to, set up the coordination and to focus. All right. And okay, once you find out the moon's coordination, like the declination and the right ascension, then you get the target coordination, uh, declination and the right ascension. It's the same way as the moon. Then you can able to check with your setting circles on your telescope, the right ascension declination. Then you move over to the target where it should be. All right. They not only the moon, but even a bright star Sirius. Now Sirius is on the meridian in the local morning hours around late summer, mid morning hours, like 10, 11 o'clock, between 10 9, 10 o'clock in the morning, local time. And in the late summer, like late August, early September, Sirius is right in the meridian. But if you know exactly where's the meridian from your location, you can able to spot Sirius. Now, even Sirius, you set up the coordination and the right ascension. Once you set it up, then you can move to your target coordination, whether it's Mars or Mercury or something like that. The idea is to once you center it, make sure it is focused, because if it's not focused, if you went over to if you go over to Mars or even Mercury, you might sweep by without even know it. Just make sure it's focused. But another thing is what if it's don't if you don't have a reference, like if the moon is not out or Venus not out, and you don't know exactly what the focus is, then it could be a little more problem to work on it. If you have a focus meter and if you establish the numbers where it should be focused, then maybe you're okay. Yeah. So um, another thing is what happened if you cannot find it in the eyepiece? Well, Venus visible through the fine scope. It's bright enough to visible in the fine scope. Jupiter, if it's in the same part of the sky where your target is, and Jupiter may visible in the finder scope also, if you know exactly what to look. It might not be visible with the naked eye, but it would bright enough. If you know exactly where it is, it should be bright enough to visible through the finder scope. So, and from there, you can set up Jupiter's coordination, right ascension, and declinations to find Jupiter. So, okay, the best thing is to do is to put the telescope in the shade. You don't want to put it in the sunlight, then you get the then you have glaring, you have sunlight, then you have turbulence around the local area. But in the shade, like maybe the roof of the house or the building or even the trees, if it's in the summertime, you have leaves in the tree, will provide shade also, and that would be the safest way, though. Uh, so um, like I said, if it's any target within 35 degrees of the sun, then you have to be a little careful. It's like you have to know exactly where the target is relative to the sun. But if it's more than 45 degrees away, then then that you got a further distance away, the target and the sun will be further distance away. Then it won't be too much of a problem to look for the target that far away from the sun. So, but always always put the telescope in the shade. That's better. And not only that, it will help you prevent from pointing too close to the sun. So, okay, next. Yeah, okay. Like before you start, it's a good idea to align your finder scope so that when the target is in the crosshair, you also will be visible, yeah, in the eyepiece field. And also just make sure the finder scope is in line also with the main tube. So, once you set it up, you don't have to touch it, you don't do any when you move the telescope, then the finder scope will get banged up. Make sure you don't do that. Otherwise, you have to line up again. But most of the time, the finder scope should line up with the main tube. So, okay, like I spoke to you about, what's visible in the finder scope. Venus definitely, first of all, it's visible with the naked eye. If you know exactly where it is. So it will be easily visible through the finder scope. Jupiter, if you know exactly where it is, even though it's not visible with the naked eye, it should be visible in the finder scope. Once you center it, then you halfway done to get the coordination, right ascension, and declination. Mars is not visible through the finder scope, except to the time when it's very close to opposition, when it's low in the sky and the sun is the opposite direction. Maybe it will be visible through the finder scope if it's like close to -2 magnitude, close to the favorable opposition. Saturn, no. Mercury, no. They are not visible in the finder scope because they're too faint. All right, next. Okay. Any tip for focusing the camera? Well,
Okay, let's
Oh, that's
let,
yours?
let's
Okay. All right.
let's
Okay.
and guys, hold on. Let's pause for a second. Greg, did you have any additional comments over the section that Frank just did for getting the target centered?
No, I do the same thing though. I set up and dismantle every time too. So yeah, and set up the tripod in the exact same location. And yeah, so tips for focusing. What I do for focusing is, can you see this? I have an eyepiece, and then this would be connected to the main telescope. What I do is the night before, I get a focusing train, and I don't normally you'd go all the way in, right? Well, what I do is I go about halfway and get a nice crisp focus on the planet in the evening, so that the next day when I'm imaging Venus, all I have to do is slide this in and out, and then it'll come to a focus. You don't want to use the coarse focus because you get mirror shift, so it shifts out, and it's a real pain trying to find it. So this way, this kind of acts as, and then once you found it and it's pretty good, then I put the filter wheel in, and then the same thing. I don't go all the way in with the filter wheel. I have, some play. So it's about halfway. And then once I see it's a crisp focus, then I use the micro focuser. Okay, so that's a nice little trick I found works really well. So you avoid using that main focus knob, which gives you a lot of mirror shift, I find. Okay, next. Okay, and then you want a fine you want a fine micro focuser attached to it, right? And that's very helpful. And I use a fire capture, so they do have some sort of helping to focus, but I never use that. I don't know if Sharp Cap has anything. Do you use Sharp Cap, Frank? No.
No.
No, use
Yeah.
fire capture
Yeah.
too. Okay.
Yeah.
So that's basically it. It's basically, visual, and, and use this little trick here. Don't go all the way in. Just have it halfway and then slide in and out until you get a good focus, and then use the micro focuser to really bring it home. Okay, next. Okay, how do you cope in bright sunlight? The one, the two bottom ones are the best, actually. You use a blanket over your head. Go ahead, next. And I found this. Yeah, you always set up the scope in the shade. You can use a cardboard box, and then I purchased this here from Amazon, and it connects to your laptop and gives you a nice shade. And then I'll put a towel over it, and my head will be here, so that gives you even more shade. So that really works well. Next. But you do need some kind of shading, because you will never see the sun. There's too much glare, you won't see your computer screen. Okay, before we go to filters, is there any questions from the audience as far as how to find, the planets in the moon in the daylight? No? Okay. And then what I find too is when the mead slews over, it's you're lucky if it's in the field of view of the finder scope. So then just slew to the center. If it's not, just slew slowly up and down, right and left, and you will find it. It's in the ballpark. So that's the nice thing about the go-to. Okay, so what filter should I use? So filters are very useful for daytime imaging. Next. Okay. All right. What's really good, especially for Mercury? Frank and I always image Mercury using an infrared filter, because infrared. Frank likes the 610 nanometer. I use the 685, but these are excellent, because what happens is the longer wavelengths of the infrared, the atmospheric scintillation is not as bad. So if you look at it visible, it's scintillating like crazy, and if you look at it in the infrared, it's not as much. It's much less scintillation, and so you can get a better image. And when you take the video, there's a lot less of this and more of this. and that's what you want. And so remember, visible wavelength is between 400 and 700. So so right here, 400, well, 3 to 400 will be in the infrared, which it's not shown here, but 800 and on is the infrared portion. And this long pass filter starts at like 610 over here, or 685 here, and then goes all the way up, and then goes all the way through, and it's 90% quantum efficiency. It's really good. And for UV and ultraviolet filter, uh, Venus is amazing because you're actually able to see the high atmosphere sulfuric acid clouds in the ultraviolet with Venus, and I'll talk more about that in a bit. But there's also a deep infrared filter, which is 1,000 nanometers, which is way out here, and this you can image the night side of Venus. And that's kind of a special thing. But get a 685 or a 610. And I found out serendipitously that I purchased the Beta 610 nanometer filter, and I found out from Cloudy Nights that that is equivalent to using a 25, a Raton 25 red filter. So if you don't want to purchase the 610, just use a Raton 25 red filter, which you basically use for Mars anyway, and that will work. That'll give you the 610. Okay, so next. Now there's an excellent specialized, can you all see this? Comes in a nice box. It's only $78, 26 bucks a filter. You can't go wrong. From Astromania, just Google Astromania specialized planetary filter set. And it gives you an ultraviolet, infrared, and methane. And so this is really, really works well, and to get you started. And here's the IR is about 650 nanometer, the UV, and then here's the methane, which is 889 plus or minus like 18. And but if you really get into this, invested into it like I am, you want to get the upper end filters. And so what I get is the Chroma U Bessel is 275 for the ultraviolet, and the Beta 685 is only 98. And the Chroma is a great company for these filters. Jovian Methane is also 275, and I have them all in this filter wheel here. And so, but if you're first starting out, purchase this for 78 bucks, and this will get you started. And you'll see some IR leak in the UV, and it won't be as the UV, especially the chroma, goes all the way up here. It's you get much more light in the UV. But start out with this first. It does a decent job. And also, I found that for the UV clouds of Venus, you can also use a Raton violet number 47. If you use the deep violet number 47, that will also show the clouds of Venus. But the UV filter is much better. Okay, next.
Hey, Greg, I
Yeah.
have a question. So I've heard about the issue that I have heard that at times with the UV filters, and you just referenced the quality, that they tend to have a little bit of IR leakage. So
Right.
I usually, a lot of times, will add in like an IR block with my UV filter. Is that anything that you do, or have you considered that?
Well, a lot of the well, it must be just an IR block. A lot of the filters are
Correct.
UV IR block. In that case, you're blocking the UV, and you're not going to
No,
see
no, no,
it.
no, just an IR blocker.
Oh, just an IR block. Yeah, you can do that, piggyback. Yeah, I've never tried it personally, but it makes sense because with these inexpensive filters, you do get IR leak. In the methane, you'll probably get two, because it needs to be a narrow band for the methane for Jupiter, And Jupiter looks really cool, looks alien in the methane. You're getting you're getting a different cloud layer in there, and it just looks like nothing you know, not like anything in the visible. But yeah, I never thought of that, but yeah, that would work. But make sure it's not a UV IR cut filter.
Right.
Yeah.
Otherwise,
Yeah.
you're shooting yourself in the foot. Yeah.
Right,
Yeah.
right. And another thing too is if you're imaging in color, one shot color, always use a UV IR cut filter, because I found this from personal experience. Before I you know, had the filter wheel, I was putting the filters on manually, and one day uh, I was imaging one night Mars, and I couldn't get a tight focus. No matter what I did, the focus stayed very soft. I didn't understand why, so I took it out, and I forgot to put the UVIR cut filter. Once I put that in, it got nice crisp focus. It's amazing, because these can you go back one? The current CMOS chips are all very sensitive in the infrared. They use the security cameras so they can see in the dark. See this IR here? See, that's very sensitive. Here's 700. So you need to cut all this out here. All right. And if you don't, that's going to come through and it's going to soften your image, and you're not going to get a good tight image. So always use a UVIR cut filter if you use a one shot color camera.
But just to clarify, when you're saying that, you're not doing that if you're doing IR or UV filter. So in other words, if
Right,
you're
right. No,
right,
you don't
so you're
use
talking
it.
about evening time standard
Evening,
color.
evening time standard, right,
Right.
exactly.
All
And
right.
if
Yeah.
you want to image Venus in visible, then you want to use the UVIR cut. But the infrared image of Venus appears basically equivalent to the to the visible, and same thing with Mercury. So you want to use the IR filter, not cut, but the IR long pass filter, to let in the infrared and, you know, stabilize the atmospheric scintillation.
Right.
Yeah, Jim, I just want to mention when you about the Radium 47 violet filter. Yes, it has the infrared leakage. Now, if you look at the graph, you can see the ultraviolet part that's up and down. Then it stays flat. Then toward the infrared, then it goes up again. All right. Yeah. Um, if you don't have an infrared blocker filter and you image Venus with the Radium 47, the detail will be kind of washed out because you're going to have an overlapping with the infrared and ultraviolet image on one top and another. So
Right.
the infrared
Huh?
images, it will be kind of washed out.
Oh,
So
here in a
that,
little bit, we're gonna go to an
yeah,
ASKC meeting.
See,
yeah.
Mm.
Uh, so yes, so the infrared blocker will help to not completely block out the 100% infrared, but it will reduce the infrared in order to image
good,
with
Yeah.
the
good point,
ultraviolet.
Frank.
Yeah.
Absolutely.
But the point too, Jim, is if you buy these high end filters for 275, the Chroma U Bessel and the Chroma Jovian methane, you don't need to add anything. These things are very tight. These things are very well made, and so you don't need to piggyback any other filter on these. There,
Gotcha. Okay.
that's what you're paying for. You're paying for, you know,
Sure.
no IR leak.
Right. Greg, I did see in the chat that somebody asked if they could have the URL for this set. So I don't know if you have that at hand. If not, we will definitely add it uh, to the YouTube
Uh,
video in the comments. But if you happen to
You
have
could
the link to
just Google Astromania specialized planetary filter set.
Yeah, I've already made a note to do that, so
Okay,
we'll add that to the YouTube.
and there's
thank you, Tim.
different companies that sell it, and it's basically $78. I mean, you can't go wrong. You
Yeah.
know?
Before we go on, because I know we're about ready to start with some of the examples with Frank, does anyone else in the audience have questions or
Yeah, on the
comments?
filters.
All right, I guess Frank, take it away with some of your work.
Okay, why bother? Well, okay, normally you don't image planets in the daytime because you always see them at night, right? But there are several time or specific events that it may be necessary visible in the daytime while it's not visible in the nighttime in your area. Let's for example, Mercury. All the images of Mercury you see on the ALPO websites and all taken at daylight because that's the way you get the most out of Mercury, the most detail as possible on Mercury. Now, the shot you see on the screen, it was taken in the daylight, near close to the meridian, as high as possible. You could never get an image like that when it's low in the sky, either toward the east or toward the west. Now, unfortunately, I don't have a good eastern horizons, and I'm not an early riser. But I always wait when Mercury gets high in the sky. Then when it get like maybe 10 o'clock local time, that would be the bedtime, right before the meridian, and the sun would block the behind the roof of the house, you know. And don't forget, Mercury has a small angle separation, 28 degrees, and that's not very far away as compared to Venus. Venus can go as far as 47 degrees away from the sun. With Mercury, most of the time, it's like between, on the average of 20 degrees away from the sun. Depends on the location and the time of the year, whether you're in the northern or the southern hemisphere, and if it's north of the ecliptic or south of the ecliptic. So they make a lot of make a lot of difference. Difference. Um, Now, a red filter is the must. Not only it compromises the resolution and the atmosphere turbulence, but it darkens the background. Now you see the background of my image of Mercury right here, so black. So you assume it's taken at night. No, it's taken a full daylight time. That's what the red filter can do to increase the contrast and blocking all the blue light from the background so it appears darker. And at the same time, it increases the contrast on the surface of Mercury. Now, what you see here, you see all the blotches here, those are crater rays and something like that. And on the right, you will see the Wind Jupiter stimulator, and that's what Mercury looked like at the day I was observing. And believe it or not, it matches very, very well. It's consistent with one another. And that's amazing. This is one of the fine shots. And this is the shot that you got to do when you want to get most out of Mercury in the daytime, when it's high in the sky, and you get less turbulence and all. But I would recommend in the mid-morning, not in the afternoon. In the afternoon, then you have increasing of heat in the atmosphere from the sun. Then you get more clouds build up. Maybe you get more winds build up. But in the morning hours, like 10, about 11, 10 o'clock local time, and the sun is still light low in the sky, and that would be the best time to catch Mercury in daylight. All right, next. Okay, same thing with Venus. Now Venus is a little easier because it's visible in daylight and all, and it's much further away from the sun. And if you plan to do ultraviolet imaging, also it's best to image Venus when it's high in the sky because when it's low in the sky, the ultraviolets cannot penetrate much to the dense part of our atmosphere. You can see by the sun. When the sun gets lower, it turns reddish, right? And all the blue light is being blocked off. Same thing with Venus. When you're doing ultraviolet imaging, when the Venus are low in the sky, it won't come out good, or you have to increase the shutter speed, the time exposure, and then you're going to have a lot more turbulence. So when it's high in the sky, you have more ultraviolet light seek through the least part of the atmosphere, and you get a short exposure, you get a clearer image, and that's the best way to do it, you know. And also, it's dark in the background too, and so that's what appears better contrast when it's
Frank,
much higher in the sky.
Frank, do you use
Yeah.
the Barlow for the
Yeah,
Mercury?
and secondly, yes, I use the Barlow to increase the magnification. Now, that depends on the type of camera you use, or the telescope, the focal ratio. From the 10-inch telescope with f10 prime focus, Venus a little bit too small. But if you want to use increase do the magnification, then you use the 2-time Barlow lens, which is double the magnification. Then you were able to get a clearer image of the detail. Yes, it's like I said, the type of the camera used, how many microns per or pixel. So I think Greg will know more about that, about the size of the pixel, if you want to image of Venus in a prime focus instead of using a 2-time Barlow.
Also, that filter Frank's using is another high quality filter, the Astrodon U Venus. So
Yeah,
that's
exactly.
also another one that you can purchase instead of the Chroma. I couldn't find that one. That's why I went with the Chroma online. So I had more troubles finding that filter. But it's
Yeah.
about the same price.
Also you see the type of filter, the Astrodon UV Venus U Venus filter. Yes, it has no infrared leakage, so you can use that filter alone, and that will do it.
Alone. Yeah, exactly. And notice the infrared, you can see the mid altitude clouds. Notice they look different than the left, the UV, which is really fascinating, you know.
Correct.
Okay.
Okay, next. All right. Also, there's another image of Venus taking daylight, but in a different way. This time, Mercury was at a inferior conjunction, well north of the sun, and this was taken in daylight also. But at inferior conjunction at that time, Venus was no more than 5 degrees of the sun. Wow, that's pretty close. And it's very dangerous, but you have to prepare well in advance if you plan to do something like this. Now, this time, this picture was taken when Venus got a little low in the sky. The sun went behind the roof of my neighbor's house. And clearly, Venus was just north of the roof, and it was visible through the finder scope. There, bang. I image it with use the red filter because within 5 degrees of the sun, it is very, very bright in the background. So the red filter helps to reduce the brightness. And it's not too bad. And also with a little bit of time exposure, look, I pick up the halo around Venus, a complete 360 degrees halo. And that's kind of rare, very close. But even though it's only a little less than 5 degrees of the sun, very rarely it can develop the halo. But you got to be within 3 degrees of the sun, which is very dangerous. I probably will never try that. But anyway, again, use the red filter. The red filter will help to increase the contrast, and that's why you can see the halo around Venus. So, now, unfortunately, now Venus and Fairies in conjunction tomorrow officially is too far away to pick up the halo, uh, closely to 8 to 9 degrees north of the sun. Even though with the red filter you might you might pick up the extension of the cusp, it's like a little more than 180 degrees semicircle, but not a complete circle. So it's too far away from the sun. So, so this is one of the fine examples you can image Venus in daylight. Okay, now the next image. Okay, well, this is not exactly daylight, but it was in the bright twilight, just maybe about 5 minutes after sunset that I image of Venus, the dark side of the Venus. Now I used the 1,000 nanometers filter equal to 1 micron. It's the Scott 1,000 nanometers, and that is the wavelength that can able to penetrate through the dark side of Venus, through the atmosphere on the dark side, and able to pick up the surface. Now, it's not the Asian light. This is the infrared. What you see on the dark side image is it's the thermal radiation, the glow radiation from the surface. So that's why it appears. That's why it glows because of the thermal radiation. Because Venus is hot enough to glow in the infrared light at 1,000 nanometers. Because if you have other type of infrared, it won't penetrate too because there's I think that the carbon dioxide the window is open at 1,000 nanometers. Able to
And
penetrate.
also the window of Earth's atmosphere is open too. So you have two open windows: Earth's
Yeah,
atmosphere and Venus's atmosphere. So
right,
that's
correctly.
why we're able
Uh,
to image it.
Okay. Luckily, the camera is sensitive enough toward the very end of the infrared wavelength at 1,000 nanometers. We cannot see with the naked eye. Our eye can only see up to 700 nanometers, something like that. But the camera got a wide range of spectral responses, and luckily, as an amateur camera can able to detect the light from 1,000 nanometers, the very end of the infrared wavelength. So. So this had to be, yeah. So once again, it had to be just 5 minutes after sunset that I took the other day. Okay, Mars. Um, okay, Mars. You always see at night, and during when it's at night, it's close to opposition or. But during the solar conjunction, right after solar conjunction, you can see Mars very low in the eastern sky, right before right before sunrise. Unfortunately, Mars is very, very low and very, very small. Um, I don't have I don't have a good horizon. So if I want to follow Mars, I must wait to get until high in the sky. Now, at that time, Mars was only about between 5 6 odd seconds, so that's really small. You're not going to have a good image of Mars when it's that low in the sky if you go after the 5 6 odd second Dix diameter. So one of the best alternate way, got to wait when it gets higher. Now, fortunately, when it gets higher, that means it's going to be daylight. Okay. Um, so at that time, last summer, uh, luckily, I have Jupiter nearby and also the moon. Um, when Jupiter was close to the meridian, I could able to find it in a scope, in a little finder scope, and get into the main tube, make sure it's focused, and get the coordination, the right ascension declination, and you get Mars coordination, declination, and the right ascension. So once you get that, then I can able to swing where Mars should be. And sure enough, with a little surge, it may not be accurate in the center, but with a little surge, go up or down or off to the side or off to the field, you may have to move around a little bit. Sure enough, you can find within a minute. It might not be very bright, but surprisingly, even at the first magnitude or zero, no, like 0.5 magnitude, it's bright enough to see it in the daytime, into the main scope because they have a high surface brightness and it takes high magnification really well. Okay, at that time, as you see the very nice image of Mars at 5.6 odd second, you can see the detail very clearly. And the black and white images you see on the left side, you see an eye of Mars, solid lacus, right above center, and that's black and white. And one on the right, it's color. So I took black and white photos just to make sure it will come out. But color's a little tricky because you have a background light to deal with. If you look carefully, you can see a little bluish color around Mars, the color image. You see a little bluish tint. Yeah. So that's because it was taken in daylight. And with a little processing that you do, is trying to eliminate the background light as much as possible. And you see a little bluish tint, but that's more I can do. But compared with the black and white, it's a lot easier because you can deal with the contrast a lot better, especially using the beta 610 nanometers long pass filter. It would help to reduce the sunlight of the background, the blue background, and increase the contrast. That's an amazing picture, and you can follow all the details now. Now, Saturn, normally you don't image Saturn or Jupiter in the daytime because you always wait to see them at night and image it. But I accept if there's any special event taking place, either Jupiter or Saturn. So in this case, Saturn, at that time, last December, it was Titan shadow crossing Saturn's disk. Oh wow! It's very rare. You never see this before. But according to my location, it will occur in daylight. Ah, so how can you? No, how can I find Saturn in the daytime. I mean, now you got to go after Titan shadow. If I wait until when it's dark, it would be all over. But luckily, Venus was nearby. I would say about maybe about 15 degrees away from between Saturn and Venus, or maybe 15 to 20 degrees, if I remember correctly. So Venus was easily visible. This is at about 45 minutes before sunset, and it was scheduled. Titan was scheduled to cross Titan's shadow. It's scheduled to cross Saturn's disk. Oh, I'd love to see that, but it occurred in daylight. So luckily, Venus was nearby. I got Venus in the main tune, set up the coordination. Then I set up the coordination for Saturn and make sure it's focused because Saturn's very, very faint and the contrast is very, very weak. So once I set it up, the coordination, the focus, and all for Venus, then I swung over the scope to where Saturn should be. Luckily, it was just on the off edge. So I move a little bit. It wasn't very bright, but it was faint. Okay. And so I hook up the camera. This is about 45 minutes, half hour before sunset. But gotta hurry up because Titan Shadow are gonna move off the disk. It's just a matter of half hour. So luckily, I hook up the camera with the red filter to help increase the contrast. And sure enough, you see the picture and Titan would capture right, the shadow would capture right along the edge of the Saturn's disk. Not only that, but you see Titan on the upper left side of the two image. You see like a little star there. I pick it up, 8.5 magnitude Titan during the daytime. I was stunned. I mean, I don't expect that, but at least the shadow is very clearly seen in daylight. So, so that's one of the reasons why sometimes it's necessary to try to image Saturn or even Jupiter in some cases, if it's necessary, to capture any special event that it won't be visible at nighttime.
Perfect. Thank you, Frank. Greg, why don't you go ahead and give us some of your examples of work here?
All right. Well, this is with Venus here, and with the Chroma U Bessel. See, it's very tight, 320 to 380 nanometers. So you have 60 nanometer bandwidth, and quantum efficiency is like 95%. It goes way, way up. If you look at that other filter, it was only like 60%. So you get what you pay for. So you want this, and then the clouds are actually the dark ones. So it's not like what you think of, on Earth, the clouds are white. Here they're dark because there's an ultraviolet absorber, unknown ultraviolet absorber on Venus clouds that absorbs the UV. That's why they appear dark in the image. Isn't that beautiful? And they change every day too. So they're not predictable, which is really cool. So people always think, Venus appears rather vanilla. It's just white. And the only interesting thing about Venus is the phase. So a lot of, planetary observers will not bother with Venus because other than the phase, it's not, you don't see much. It's not like Mars where you're seeing, the beautiful albedo feature Syrtis Major, and and Jupiter you're seeing the cloud bands, and Saturn the rings and also the cloud bands, but you also see clouds here on Venus, but you just need a high-end ultraviolet filter to see them. That's all. And I think it's fascinating to be able to see the cloud bands of Venus. And you need it at, if it's a thin crescent, obviously you're not going to see anything. So you need it more gibbous and first quarter phase in order to really see them. But see, you can tell they're very different on different days. So that's basically, so Venus is very interesting. And also you get mid-altitude clouds in the infrared. So here's what it looks like in the infrared. If you look very carefully, you can see there's some banding there. And this is in the infrared. And like I said, this basically looks like the vanilla image you'd see with a UV-IR cut filter if you're looking at Venus. But if you look carefully, you can see some darkness here, and then you can push the processing a little bit. So Venus in the infrared also looks fantastic. Okay, next. And then here I was able for the first time ever to image, Venus in the the night side of Venus. And here's the WinJupo simulation here, and here it is identified, and you can see the features here. And what's cool is you got to use some tricks with this. Normally, you'd never use a focal reducer, for a planet. You don't want to make it smaller, you want to make it larger, right? But in this case, you want to use a focal reducer. And then turn up the gamma, I found too. And then what you want to do is double up on your filters. I use this Torrent Photonics 1010 plus or minus 38 nanometer. This is a high-end filter. This is about just under $200 for 27 millimeter. And what I find is that it doesn't come in a filter cell. It just comes as the glass filter. So what you have to do is you have to place it in a filter cell, which is no big deal. And then I doubled up by adding the Antlia 850, and I believe it'll be better. I saw people on the HST Jupiter groups that did this, and they're using two 1 micron filters. So I need to get another one of these filters instead of using this. So next apparition, I'm going to try that. But see, you can definitely see the features here. I mean, it's incredible. You're actually looking through the sulfuric acid clouds and looking at volcanoes and albedo features on the surface of Venus. How cool is that? So Venus is not as plain as you might think. There's a lot going on Venus, but you just need the right filters. You need a high-end UV, a high-end IR, and this 1 micron filter to actually see it.
Roughly
And
5 minutes.
Okay, and then these are my images of Mercury, and Frank processed these for me and also identified the different features. This one was an exception. It was on July 4th, actually, and on the morning of July 4th. And look at that. You can definitely see a lot of features here. So that's basically it. And always image Mercury in the morning apparition as it's getting higher and higher. And I tried in the evening as it's setting, and there's just way too much atmospheric scintillation. You see nothing. It's just don't even waste your time. You're not going to get anything. But in the morning, so any closing questions or?
Well, okay, so I have a question.
Go ahead.
Okay, maybe you addressed this, and maybe I missed it. I mean, other than the fact that it gives you more viewing hours, why do daytime observing?
Well, maybe I can answer that. Well, no, like I said, normally you observe the planets at night, but there's certain times that you cannot get a good image, especially when it comes to Mercury, Venus, because they're always low in the sky when they're visible easily with the naked eye. Because you have looking through the long turbulence of our atmosphere, the long path through our atmosphere, then you want to get the best images possible. There's no way you can do that, but you have to wait until when it's high in the sky, which means it's daylight, and that's the best way to do if you want to get the most out of the detail, either Mercury or Venus. So,
Okay,
and
good.
they brighten up. They have a high surface brightening, and they brighten up to the eyepiece.
It's kind of like the same reason that you would use an atmospheric dispersion corrector when it's lower, because you've got, the more the atmosphere that you got to go through, the more difficulty you're going to have getting a quality image. This particular technique can allow you to grab things when they're much, especially the inner planets, when they're much higher in the sky.
Right.
Okay, good. Thank you very much.
Anyone else have anything that they would like to ask our presenter?
Mike did too.
Yeah, John's got his hand raised.
Thank you. The question about using the atmospheric disperser, have you ever used that along with the filters? And I assume when you're talking about using two, you're double stacking them. So can you double stack filters and an atmospheric dispersion tool. I'm sure that you're talking about the ZW over one.
Yeah, I tried that atmospheric. I've never had much success with it. I don't use it, but you can double stack the filters. If you notice the daylight, I use two filters, screw them together: the Antlia 850 long pass and the
And they
1010.
fit in your filter wheel without any
Oh yeah.
problem?
Well,
Okay.
one is in the filter wheel. One is in the filter wheel, and one goes out here.
Ah, thank you.
Yeah. So why? So I put the 1010 here and the Antlias in here, and then the cameras here. See, so
Makes
And
great sense now.
I would say that, also an ADC is more appropriate, I think, when you're doing a color image, when you're getting, you have the blue light and the red light and
right.
everything, and together you get the blurring. If you're putting on a filter that's like narrowing it down, I think an ADC brings less to the table.
Yeah, it does. It does. You're monochrome and you're in infrared every time or ultraviolet. So yeah, you're in monochrome, UV or IR, and yeah, it's just going through more glass, and then you gotta
Right.
fiddle around with it, and you're losing precious time because the planet is setting.
Okay.
So you're losing altitude.
John,
Thank you,
Okay.
John.
Greg, is that the motorized one? Do you have the motorized the color wheel?
Yeah, no, this is actually
Manual?
hand, yeah, manual, yeah,
Okay, I have the same one. Yeah.
yeah.
All right,
And we
but
had
that's a
a,
little smaller. You have how many filters can you put in there?
This one has 9.
Oh, okay. I have up to 5.
And I
Yeah.
have them all labeled. Yeah.
Yeah. Okay.
did
Okay,
we have
Mike.
another question from the audience here as we wrap up? I think,
Mike
Mike?
has one. Yeah. Mike.
Right.
Hi, guys.
Yeah, go.
Thank you. First of all, thank you so much for your presentation, Greg and Frank. Really appreciated it. I noticed that seems like by default, the camera to use is more of a monochrome camera when it comes to daylight imaging. Just because you don't have to worry about the colorization that you have, that cast that happens when you take a color image. Is that a fair question? Assumption?
When you come to filters, monochrome camera is the best option. Best option because you have to deal with different wavelength, the blue, the red, any
Right.
color. Yeah. But you cannot do with the one. I assume if you talk about one shot color camera or what, um, then you have uh, the colors be a little washed out because of the daylight and would throw off the color balance. But
Right.
if you want the black and white camera is the best because that you're using the filters to isolate the wavelength, and that's where you get the best images.
And you're
Except
getting
yeah,
and
and
you're getting higher resolution
yeah,
with monochrome because the color has red, green, blue on each pixel, has a filter on each pixel. So you're losing resolution, slight resolution, whereas the monochrome is just shades of gray. And when you're in the infrared, there is no color. Color is between 400 and 700, and you're way beyond that. And the ultraviolet, you're between 300 and 400. And so there's no color there either. So, you're increasing resolution by using a monochrome camera.
And
You
I'll
could
just go ahead.
use a color, but you're spinning your wheels because then you got to balance the colors. You're losing some resolution. It isn't worth it. You always use a mono.
yeah. You see
And I
one
will
color
mention,
oh, I'm sorry. You see one color image of Mars that I just posted before. Yeah, that was taken daylight. I have to do a little process and correct the color balance to uh more natural looking, and I did pretty good job on that. And so yeah, they have to work it out with the color, especially the balancing level to get a
just,
more appropriate thing.
just a quick note in terms of this topic. I think Sony has just come out with a new chip, which supposedly is much better in the infrared in terms of its sensitivity. So, you may want to, if you're thinking about getting a monochrome camera and getting into this, definitely be sure to check that out.
It's a
What's the
DWO
model of
camera.
the chip?
It is a ZWO, but others like uh, Planet One or whichever
Oh,
QHY.
planetary one. Yeah,
Planetary One, QHY, they all are
yeah.
beginning to use this new chip from Sony, which has a much better quantum efficiency in the infrared.
I
So
think
any
the
other
one.
questions? Because
Oh,
we're
before I
5 minutes
go,
over.
Before I go, Jim, I think the one you might be referring to is the 585. Since
Yes,
it's,
sir.
yeah. I have that one for color. It's fantastic. I use it all the time, and for sure, guys, I completely agree. Monochrome is the way to go for daylight. I was just curious, just because Jupiter's it's great position now. If you can catch it in the daylight, it's getting closer to moving into the twilight hours. I just thought if there's a chance that if you had a technique that involved that would color balance that somehow in the with using a color camera, I'd be curious to know that. Otherwise, it looks like we're going to be using only monochrome cameras for capturing the Jupiter at its highest anyway right now.
Mike, are you from Canada?
You
Mike.
betcha.
Yeah. Oh, yeah. You're from Canada, right?
Yes.
Yeah.
Yes.
Okay. Yeah. I've seen your picture of Mars, and I remember your name and the town and the location. Yes. Okay.
I may trick you a little bit though, Frank, because like Greg knows, sometimes I vacation down in Curacao and I do imaging there too. So I'll have my name by Curacao, but the other months of the year I'm back here in Canada for sure, and with a much more challenging scene conditions than it is down south. That's for sure in the Caribbean.
Yeah, you've done some fantastic imaging. I'd urge people to go out to the galleries and check out some of Mike's work. Just really great stuff. So,
Oh, thanks, guys. Appreciate that. It's nice of you to say.
Yeah.
so Tim, you want to take us out?
Yeah, well, I want to thank um, Greg and Frank for giving great presentations today, and Jim for helping set this up. We currently, well, at Maxim, we had 8 people on YouTube watching us live as well. And if you're over on YouTube, please give us a thumbs up. And if you have not yet subscribed to the YouTube channel, please do that. That always helps the ALPO and our channels as well. So, Jim, do we have another one of these set up for the near future?
Not at the moment. I'm trying to orchestrate one, but as soon as I have that nailed down, I will let everybody know. But of course, Tim put in a plug for our conference, which is not really that far away. It's in July.
Yep.
And, the ALPO conferences are always great, I think.
Yeah, July 25th and 26th. So it's going to be on Zoom. So I'll be calling for papers in the next month or so. And if you're a member of the ALPO and want to present a paper, please let me know. And also, if you want to attend, like I said, it's all going to be on the YouTube channel, simulcast on the YouTube channel, and also on Zoom. So you're all welcome to be a part of that.
Awesome.
All right.
All right. Thank you, everybody, and especially our presenters. Appreciate it.
Okay.
Thank you, guys.
Thank you.
Thanks. Bye.
Bye-bye.